I want to go back and revisit the formal definition of the limit that we talked about in the first video, and we've been applying for all these other videos. So remember that the definition was that if you have a function and you're approaching some value a with x, then you get some value y, and they called it L. And up until now, we typically got a value, and I'm going to remind you what I'm talking about. For example, if we had the limit as x approaches -2 of x plus 2 over x squared minus 4. So we would look at this and say, well, is -2 in this function's domain? And we would test it, and this would give us 0 in the denominator. And so one of the things we would attempt is, could we do something to transform it into a function that the drawing was essentially the same except for the hole. This one has a removable discontinuity. So this -2 gives us 0 in this factor, this binomial right here, and we can cancel that out and in fact remove the discontinuity from the figure and evaluate this. And then we could take the -2, substitute it in, and have 1 over a -4 or a -1/4. And remember, you should always have a nice complete sentence. Now, I picked these problems to give us removable discontinuities, and we're going to talk right now about some that don't do that. That's the purpose of this video. So we're going to look at this figure and discuss f of x, which is 2 over x squared minus 1. Now, if you look at the denominator, you can tell that x squared minus 1 cannot be 0. That's what you've learned in algebra about the domain. So x cannot be plus or minus 1. And as you can see here, there's an asymptote at plus and minus 1. All right. Now, let's talk about the limit. Even though we're not approaching a value like a fourth or 23 or 3/2 or 5 or something, we can still take that basic definition, and I'm just going to call this f of x. But this is f of x. So we're going to look at the figure and we're going to discuss this. So even though the formal definition said you're approaching a value L, a numerical value of some type, if we think of it as, okay, this is not approaching a numerical specific value, but it is kind of heading off in this positive direction without bound. And they would say that this is heading off to positive infinity. Okay, so let's talk about this. And you would say, all right, the limit of this function as x gets closer to 1 from the right is heading off into positive infinity because it's heading up without bound. There's little arrows here. So from the right coming into 1, it's heading off to positive infinity. So even though it's not a specific value, it's kind of a direction. All right. Now, I'm putting the plus infinity there so that you'll be sure and keep up with the fact that it's positive. I've actually had students on a test, and they'll put a little mark right there and put infinity. And then they'll try to tell me that, depending on what the answer actually is, Oh, that I'm not trying to say negative infinity. That mark doesn't have anything to do with it. So I make y'all put plus infinity and minus infinity on your tests. And it also makes you think a little harder. Now, whatever your teacher wants you to do, obviously, is what you're going to do. So let's look at -1. Let's approach -1 from the left. And as you can see, I'm heading down. And so this is negative infinity because they keep heading on down forever. Then the limit as x approaches -1 from the right. So here's -1. We're approaching it from the right. And again, we're going down to negative infinity. And the limit as x approaches -1 from the left. So coming up to -1 from the left, you're ripping up here to positive infinity. Okay? Now, if you can see right here on either side of this one, this one's going down to negative infinity. This one's going up to positive infinity. So they're not even going in the same direction. But if we had had something that was going like this, let's say this is 1, then we could say that the limit from the left would be infinity, and the limit from the right would be infinity. So we would then say the limit of the function from both sides is infinity because we have an agreement in the direction. Okay? So now we're going to expand this concept. I'm going to get a number to the concept of I'm going off in a direction. Keep in mind that what these are in effect doing or analyzing are vertical asymptotes. This will come in handy when you get to the part where you have to graph using the calculus. Now, most of the time we don't already have the graph. We're going to try to use this to graph. And sure, if you have your graphing calculator, you can double check these on your graphing calculator. But depending on your teacher, they either may not let you have the graphing calculator, or they're going to want to see your work. And then what you verify it with is up to you. But if you want to see the work, let's come up with a way to do this without a figure. So let's go back to this. F of x is equal to 2 over x squared minus 1. I'm just going to go back to this, and instead of using a figure, I'm going to try to analyze it. Okay? Now, we know that around 1 and -1, okay, we know that there are asymptotes, vertical ones, at x is plus or minus 1, because from our college algebra class, right? So what I want to do is I want to talk about the limit as x gets closer and closer to 1. And I'm going to approach it from the right side this first time. Okay? So what we're doing is we're going to get closer and closer to 1 because I can't make the discontinuity be removable, because even though I can factor it, there's nothing for it to cancel into. So these are non-removable discontinuities. So you can't cancel anything out. And you have to do what I call sneak up on it. Okay? So we are going to sneak up on it. Now, you could call it something fancy, saying, you're going to get closer and closer to x is 1. They have these epsilon delta proofs that say how close you actually have to be. But it makes me smile to say sneak up on it. I hope it makes you at least feel like a game you're participating in as opposed to math you have to put up with. So I'm going to call it sneak up on it, right? So I am going to sneak up on 1, just the number 1. So I want a number really close to 1 that's on the right-hand side. That doesn't mean 2 or 5 or not even necessarily 1.5. I want a number that's really close, like 1.001, something like that. Okay? And I am going to try to figure out what a number kind of in the vicinity of 1.001 is going to do to my function. Okay? Now, so what you're going to have is, if you actually put that number in, you would say I would have 2 over 1.001 squared minus 1. Okay? Now, would you grant me that 1.001 squared is just a little bit over 1, and then you subtract 1 from it, it's going to be pretty small. So what this turns out to be, and we don't actually need the limit once we put the number in, it actually computes to being something like 0.002001. Now, which, if you keep computing, is 999.5. Now, I sometimes see students who will write down 999.5 or 10,000 or 892.4 or something like that. This is just an indication of where it's going. It actually doesn't ever stop going that way. So if it's gotten up to 999 already, it's going to keep going. So what I want to show you is just to kind of explain this a little bit. If you take, let's take a random number and take 5 and divide it by 0.1. Okay, that's kind of small. But 5 divided by 0.1 is 50. Let's get it to be even smaller. 5 divided by 0.01 is 500. 5 divided by 0.001 is 5,000. So do you see how the smaller the denominator gets, the larger your result gets? It doesn't matter if this is 5 or 50 or, any number divided by a little tiny number is going to give you a huge number. Okay? So if this is tiny, dividing by a tiny number gives you a huge number. Now, I know I'm actually trained as an engineer, and every engineer out there is going, what's a tiny number? All right. But again, anything you can do that kind of entertains you while you're doing math just has you do it a little easier and with a smile as opposed to with a frown, because you have to do it, so you might as well do it with a smile. So I have a number 2 divided by a little tiny number. I'm going to get a big number. And all this means is that I'm effectively getting to a really large number without bound. You could get it, excuse me, a little bit closer. And you could have said, okay, what if it's 2? And I get a little bit closer and have 1.0001 squared minus 1. And this would be, give or take, around 9,999. So see, as I get closer to 1, this blows up more. Okay? So getting closer and closer and closer makes you divide by a littler number. Sometimes I call it a wee little tiny number. Okay? So the smaller it is, the bigger your value is going to be. So what this means is that I'm heading off in an increasing positive direction without bound. So the limit as x approaches 1 from the right of 2 over x squared minus 1 is going to be positive 50. Okay, that's how we're going to determine it. All right. Now, let's try a few of these. All right. Here's the function 1 over x minus 4. I don't want to draw it. You can always confirm these with your graphing calculator, but let's explore the math. You really need to start developing kind of a gut instinct for numbers. So let's just start now. Now, since it says x approaches 4, it is understood by you that it's asking you for a left-hand limit and a right-hand limit. Up until now, we found a way to either factor or multiply by the conjugate, clean up complex fractions. We found a way to get the denominator, which was equal to 0, and had a discontinuity. We figured out a way to get it to kind of clean up and become a removable discontinuity. But right now, we can't remove the x minus 4. We're curious about 4, so we just have to figure out what's going on. Okay, so this is a non-removable discontinuity. So instead of just substituting the number into a transformed version, we are going to have to sneak up on it from both sides. So the limit as x approaches 4 from the left of 1 over x minus 4 is going to be equal to something. And the limit as x approaches 4 from the right is going to be equal to something. And let's see how that looks. Okay? Now, I need a number to the left of 4. So for me, I'm going to pick 3.99. Okay? You could pick 3.98, 3.97, 3.95. Y'all just pick whatever number that it kind of feels like to you. And we're going to put this in here and kind of look at it and get a gut instinct for what's going on. So we would have 1 over 3.99 minus 4. Okay, so this is 1 over, and I don't actually have to do the math. I just know this is a tiny negative number and a positive number. 1, 5, 27, 119 or whatever, divided by a tiny negative number that's getting more and more tiny negative as we get closer and closer and closer, is a huge number in the negative direction. So it's going to be negative infinity. So the limit as x approaches 4 from the left of 1 over x minus 4 is this. I'm not going to go ahead and box it in because they didn't actually ask me what the left-hand and right-hand limit was. They asked me what the two-sided limit was. So let's keep going. So I need a number to the right of 4. So I'm going to choose 4.001. You could pick 4.002 or 4.025, whatever makes you feel comfortable. So 4.001 minus 4. You don't actually have to do the math, run this on your calculator. What you want to do is to say this is 1 over some tiny positive number, because it's 0.001 in this case. But you're going to keep getting closer and closer and closer, so it's going to keep getting tinier and tinier and tinier, the difference between the two. Still positive. So 1 divided by a little tiny positive number is a huge positive number. So it's positive infinity. Now look at these two. If they match, let's say they were both going off to positive infinity, then you could say the limit from both sides was positive infinity. But they don't match. One's going up and one's going down, and so they don't match. So the limit as x approaches 4, without the plus or minus, it means both sides, of 2 over x squared minus 1 does not exist because there's not a match. And this is your final answer. Okay? Let's do just a variation on this. Limit as x approaches 4 of 1 over x minus 4 squared. Okay? Now this is a two-sided limit, so they're not going to remind you about this on a questionnaire or a homework or a test. You just have to remember that if it is a non-removable discontinuity, or anytime really, a two-sided limit is asking you for the left and the right. But a lot of times we can get away with just looking at it as a two-sided limit, if it's continuous at that point, or if I can remove the discontinuity. That's amazingly hard to say. All right, limit as x approaches 4 from the right. Okay, so I want a number to the left of 4. So again, something like 3.99. So this would be, something like 1 over 3.99 minus 4 squared. So this is 1 over a tiny negative squared. Now, a tiny negative squared is going to become positive, and it's even more tiny. So you could write we. Whoops. Let me spell that. We little tiny, for giggle, or you could just say it's small, whatever you want to do. 1 over a tiny positive is going to be positive infinity. So here's the left side. And I want a number to the right of 4. So I'm going to use 4.01. So this is 1 over a tiny positive squared. So it's an even tinier positive, or a wee little tiny positive. So it's positive infinity. Now, maybe they'll only ask you one side. You don't have to do this, but I kind of doubt it. All right. Since you have two sides set on either side of a number that are going off in the same direction, we're going to say the limit as x approaches 4 of 1 over x minus 4 squared is positive infinity. Okay. Let's try the limit as x goes to negative 1 of x squared minus 4x over x squared minus 3x minus 4. Now, it's negative 1 in the domain, and we would take it over here and go, okay, it's negative 1 squared minus 3 times the negative 1 minus 4. Before we want to see if it's even worth factoring, let's see if it's a problem, because if it's not a problem, just substitute it in. You know, teachers are, I don't know what the word is, devious like that. Sometimes you put a value in for x that's actually in the domain, and it's amazing how many students will try to do something crazy because they didn't check to see if it's in the domain first, and it wastes a lot of time. So y'all be sure and check. So this will be 1 plus 3 minus 4. Yep, that's 0 on the bottom. That's a problem. Okay, so let's try factoring. Just because we're in this section doesn't mean you can forget what it is that you're doing up before this. So you'd have x times x minus 4 over x minus 4x plus 1. And these x minus 4's cancel. But the thing that is causing you to have 0 in the denominator is this factor right here, and it is still there. Okay, so even though we have a simpler form to evaluate, there is still a non-removable discontinuity. So there was a removable one for x minus 4, or at x equals 4, but there is a non-removable one at minus 1. So what you're going to have to do is the limit as x approaches negative 1 from the left, and the limit as x approaches negative 1 from the right. and see what's going on. Okay, so sometimes I have found out that students have a difficult time going, give me a number to the left of a negative number. They can do positive numbers left and right just fine. They get on the negative side and all of a sudden they're not sure. So if you're not sure, draw a picture. I'd rather you drew a little sketch, a little picture, than to guess incorrectly. So a number to the left of negative 1, because negative 2 is down here, 0 is over here, would be negative 1.001. And a number to the right would be negative 0.999, something like that. Okay? So here we go. A number to the left would be something like negative 1.001. So let's contemplate this. So it'd be negative 1.001 over negative 1.001 plus 1. So up in the numerator you have a negative, and in the bottom you have a tiny negative. So a negative divided by a tiny negative is a huge positive. Okay? Now, a number to the right would be something like negative 0.999. So you'd have negative 0.999 over negative 0.999 plus 1. So you would have a negative divided by a tiny positive. So this is negative infinity. So what would be the two-sided limit? The two-sided limit would be the limit as x approaches negative 1 of x squared minus 4x, because it was your original problem they asked about. Does not exist, because there's not a match. Okay? Now, sometimes you just sort of have to, I hate to say, kind of reason these things out, because there's not a really simple way to set some of these up. So let's look at x approaches 3/2 of the square root of 2x squared minus x plus 10 over 2x minus 3. Now, you can't have the 3/2. It's not in this domain because you can't. It would give you 0 in the bottom. You might be tempted to go, all right, if we have 2x squared minus x plus 10 and a square root, I did learn about multiplying to get a square. So you could sit here and say, maybe if I multiply this out, because what you multiply the top by, you have to multiply the bottom by. Maybe if I multiply this out and get just the 2x squared minus x plus 10, I could get this 2x minus 3 to cancel out somehow. It's worth checking, and let me show you what you're going to check. Okay. When you look at this and you think, I'm wondering if I could multiply it by itself and get a square and then factor it down, and maybe one of its factors is 2x minus 3. Well, does this factor? Okay, it'd be a 2x and an x. How about a minus 5 and a plus? No, not a minus 5 and a plus 2. Can you think of anything that multiplies to a positive 10 and adds to a negative 1? Because they both have to be the same sign. That's a 2x minus 3. Now, you could multiply this by 2. That would give you 4x. And if you had a 5 here, this would get you 5x. And if you could subtract the 5x, that would get you a minus 1x. But that would get you a minus 10 right here. So this is not going to factor like what we want. So it's worth a shot, but let's not. Okay, so let's go back over here and let's think about this problem. If you think about the fact that whatever you put in here, okay, you're going to square something close to a fraction, you're going to subtract that fraction, possibly close to a fraction. But then you're going to add 10 to it. So whatever's going on in these two locations right here, once you add 10 to it, it's going to be positive. And the square root of a positive is positive. So this is going to be some positive number. Okay? Now remember, we don't need exact numbers to sneak up on it. We just need to know if they're positive or negative. So let's talk about 3/2. Okay? And we need a number to the right. This is 1.5. Okay? And so to the right would be 1.6, and to the left might be 1.4. Okay? But when you put that in there and you do the math, this is going to be a positive number over something. So let's do the limit as x approaches 3/2 from the left. And this is always going to be positive. And when you approach it from the left, you're going to get a negative number. So this is going to be negative infinity. And when you approach it from the right, this is still positive in the numerator, but you're going to get a tiny positive down here. So this is positive infinity. So they don't match. So the limit from both sides does not exist. Some of your teachers may let you put D and E. Better ask first. Y'all are now in upper level math courses, and because your teacher doesn't know if you're going to be a math major, they're going to teach you the proper way to say things, as they should. Okay, and I have to admit that in a lot of future classes, if you're not in a math majors course, we sometimes let the proper terminology slide a bit, but you really do need to learn this. So be careful writing D and E. They may not like that, because that's, I'm glad you know that D and E means does not exist, but does not exist is clear. Okay? So you can also ask for a one-sided limit. Now, I have to ask you, if you have 5x plus 3 over 5x times x minus 1, do these two 5x's cancel? And I really hope you're shaking your head no, because the answer is no. Because this 5x is not a factor of the 3. This 5x is a factor multiplying the x minus 1, but this 5x is not a factor. You cannot chop it off. Okay? And in an earlier video, I said, think of it as little hands holding on. That you've got this little person in between, and they are holding on to the 3 and the 5x with this plus right here. Okay? All right. Like I said, whatever makes you smile. Okay, so that does not cancel. I need a number just to the left of 0. How about negative 0.01? Okay, so you'd have 5 times a negative 0.01 plus 3 over 5 times a negative 0.01, negative 0.01 minus 1. Now, y'all, you're not trying to compute a specific number because these are going off in a general direction. So don't compute this on your calculator and then give your teacher a value. Okay? This is just indicating, because these are vertical asymptotes, that you're either going to be racing off to positive infinity or negative infinity. So 5 times a negative 0.01 is a small negative, plus 3 is going to be a positive number. Okay, now 5 on the bottom times a negative 0.01 is a small negative number. Negative 0.01 minus 1 is negative 1.01. So I've got a negative times a negative is a positive, and a tiny number times a 5 is still tiny. So this is going to be a tiny positive. So a positive number divided by a tiny positive is positive infinity. Okay. Let's do one more comparison. So the limit as x approaches 0 from the left of 1 over x minus 1 over absolute value of x. Okay, and I need a number that's just to the left, so how about negative 0.01 again? So let's think this through. So it'll be 1 over negative 0.01 minus 1 over the absolute value of negative 0.01. Okay, so this is negative 1 over 0.01. Okay, the absolute value of a negative is a positive, so this negative is this one. And you'd have 1 over 0.01. Okay, now this is a number divided by a tiny number, which is going to get tinier and tinier and tinier, because it's going to go 0.001, 0.0001 as you get closer and closer to it. So this is going to be negative infinity minus another infinity, and this is not negative 2 infinities. Okay, you can't have negative 2 infinity, right? Because what's infinity times 2? It's just infinity. You're just going in that direction. So it's just negative infinity. I get why you want to say that, but we don't have multiples. Okay, so it's just negative infinity. All right. And then let's go the limit as x approaches 0 from the right of that 1 over x minus 1 over the absolute value of x. Okay, so that would be something like 0.01. So this would be 1 over 0.01 minus 1 over the absolute value of 0.01. So this is going to be 1 over a tiny positive minus 1 over the same tiny positive, right? So whatever this number is, because you use the same number to the right on both of them, this is going to be the same number, and anything minus itself is 0. So this limit is actually 0. Now, books don't put parentheses around these, but to me it kind of looks like you're just doing the 1 over x is the limit and the other things just hanging on. So I would like to have parentheses around it, but it's up to you, your book, and your teacher. So I would kind of rather have that. Okay. Hopefully that all worked out for you. Now, be careful if your teacher is asking you to do a two-sided limit, and the way they ask that is to not put plus or minus there, they just leave it blank, then you have to show them both sides before you can make a conclusion and to get full credit. If you just throw an answer on there, a lot of teachers will not give you credit for guessing. You got a 50-50 shot. It's either infinity or negative infinity for these types, unless you have something like this last problem. So we're not going to give you full credit for guessing. If the answer is just there, you might have just been guessing. So you have to show some work, but if they ask you a two-sided limit, you have to do both sides. If they ask you a one-sided limit, you don't have to do both sides. And I actually know teachers who will count off if you do more, because that implies that you don't know what the question meant. So you just did everything you knew how to do. So be careful, right? And the next video is going to talk about the horizontal asymptote that we've talked about, because in the past we have talked about vertical asymptotes. And what we have been exploring up until now is limits on either side of a specific number. Okay? Either side of 0, either side of 1, either side of an asymptote. Okay? In the next video, we're going to talk about what happens if you get way out here or way out here. And in algebra, these were not vertical asymptotes. This was horizontal asymptote, the behavior out at the extremes. So the next video actually is talking about horizontal asymptotes. These have all been talking about verticals when you have discontinuities. Okay, that's all for now.